In the previous lesson, I have given you the assignment to try out GCO level November 2013 paper 2 question A1. So let's review it. This question states that a stone falls from the top of a cliff into the sea as shown in figure 1.1. The speed time graph for the stone is shown in figure 1.2. In part A, you are required to state how acceleration is found from a speed time graph. This is how you should answer. Acceleration is found from a speed time graph by calculating the gradient of the graph. If the speed time graph is a curve, the gradient of the tangent to a particular point on the graph gives the instantaneous acceleration of the object at that moment in time. Next, you are to describe how the acceleration of the stone changes between point A and point D. The following are the important points that you must state. First, from release, that is point A, the initial section of the speed time graph close to A is almost a straight line, telling us that the stone was falling at a constant acceleration, that is the acceleration due to free fall of 10 meters per square second. This is because the air resistance at this stage is still very small, and hence the stone was falling as if it is free falling in a vacuum without air resistance. Secondly, as the stone moves towards B and then to C, the graph progressively curved, indicating that the acceleration decreases. That is, the falling stone is accelerating at a reducing rate. This is a result of the increase in air resistance that opposes the increase in the speed of the falling stone. The increase in air resistance retards the increase in the speed of the falling stone, thus causing the acceleration to reduce. Then at point C, there is a sudden decrease in the speed of the stone, and the gradient of the graph for that section from C to D is negative, indicating that the stone was falling with negative acceleration, that is, deceleration. Finally, after point D, the graph is a horizontal straight line, indicating that the acceleration of the stone is zero. This means that the stone is still falling, but its speed is constant. Next part, you have to explain in terms of the forces acting why the acceleration changes between point A and B. Since the question specifically states to explain in terms of the forces acting, it is advisable that in your answer, you should mention what are the forces. Here's how you should answer the question. As the stone falls, two forces act on it. The Earth's gravity pull, that is the weight of the stone, pulls the stone downwards. The air resistance, which is a frictional force that opposes motion, pushes the stone upwards. When the stone was first dropped, it free falls at an acceleration of 10 meters per square second as the Earth's gravity pulls it towards the center of the Earth. At this initial stage, the air resistance is much smaller than the weight of the stone. However, as the stone's falling speed increases, the upward air resistance also increases to oppose the downward falling motion. This causes the rate of increase in speed, that is the acceleration, to reduce as the stone drops from point A to point B. In part D, you are to explain how figure 1.2 shows that the stone does not reach terminal velocity in the air. You may have noticed that the graph of the stone looks like the graph of skydiver in previous lesson. However, unlike the skydiver that opens up the parachute, the stone has no parachute. So why is there a sudden drop in velocity? So it must be because the stone drops into the water. Therefore, your answer must explain that point C is where the stone drops into the water. Here's how you should explain. From the graph, point C is the point where the stone hits the seawater, as water has a higher density than air and the opposing water resistance causes a steep retardation to the speed of the stone. Then you must say that if the stone is traveling at terminal velocity, its velocity is constant, and the speed time graph should be a horizontal straight line. Since there is no segment on the graph before point C, that shows that the speed of the stone remained constant, it means the stone did not reach terminal velocity in the air. Paper 2 questions often require you to explain or describe certain scenario. Remember to keep your answer concise, focus on what the question is asking, and be able to demonstrate your understanding of the topic in question.